Orkestra is a turnkey cloud management platform which integrates MP-Store software-defined storage solution Proviso, MP-Store storage management software MP-Stacker, and a number of OpenStack components. The Orchestra solution uses the OpenStack Nova, Cinder, Quantum, and Glance components, which sit on top of MP-Store's Proviso and MP-Stacker storage array management software, and offers a number of dashboards for operations management, administration, user access, and a complete image vault. The Orchestra can be installed in one of three different configurations: all-in-one, some-in-one, and one-in-one, where one cloud function is run on one node. And those services required by Orchestra, such as management service, the service network, public access, and data network, can be configured to run on 2 networks, 3, or 4 networks. In this particular case, we're going to look at an installation of Orchestra in a 4 network configuration. To boot Orchestra, I simply download the ISO image, put it onto a bootable device, USB or CD, whatever, and once I've booted that, I can then connect to the Virtual Block Manager. The Virtual Block Manager allows me to configure working storage for OpenStack. So once I have connected to the Block Manager GUI, simply verify that you do indeed have disks connected in the system. Go to your System tab and create a RAID. In this configuration, I've already created a RAID, and then create a volume. In this case, I've already created a volume for the OpenStack, which I've called Nginx. This is now exported to OpenStack, and OpenStack can now continue its boot process and its configuration. It now has working storage. So once I've booted my Orchestra image either from a USB key or a CD or a netboot, I simply configure all of the services. So the first service that I will configure is the management interface, and I put that on Ethernet 0, and I will choose the default values. The next is the service, the VM interface. This is the VLAN interface where all of the virtual machines from all the tenants will communicate. I'm putting that on Ethernet 1. My public interface on Ethernet 2. Again, I'm going to choose the default values. And finally, the data network on Ethernet 3. And again, I'll choose the default values. So I simply apply all of those network settings, and all of my services and Ethernet ports are now configured. The next step is to configure the roles that I'm going to run on this particular node. I'm going to choose everything except the Swift service, and my controller IP, my cloud controller IP, will be 193. So I'll now restart a number of services. This procedure just takes a few minutes. So now I'm going to choose to install a VM image so I can actually test out my dashboard. Once we've installed this image, we can afterwards to the dashboard upload any bootable VM image, any ISO or .img file. So now I simply finish the last step, which is the adding a super user. Again, I'll just use the default name and give it a password. Make sure you don't forget the password. Give it a default project. My default project will be project admin. Again, through the dashboard I can create additional projects for different tenants. Add a private network used by all of my virtual machines, and then add in a public or floating IPs If I want to attach a public IP, it'll be from this range to any of my virtual machines. And then lastly, I just export all of those credentials to my OpenStack project. And that's it. Orchestra is now set up. I just need to save everything and exit. Done. My dashboard is now available on 10.0.2.193, and we're going to connect to that now. Having completed the installation of Orchestra, the next step is to configure Proviso. In this configuration, we're going to create 3 different storage groups and 3 different compute groups. The compute groups are bronze, silver, and gold, and the storage groups will be basic, standard, and premium. And each storage group will be mapped to a different infrastructure, and for each storage group, we'll configure a storage policy. Bronze compute group will use basic storage. Silver can use both basic and standard, and finally gold can use all 3, basic, standard, and premium. And we're doing this because Proviso will then automate the provisioning of storage from whatever group through the end user dashboard, and each storage group will have a configurable SLA. To configure Proviso, simply log in to the configuration tool and configure the compute group, storage groups, and the storage policy per storage group. To create a storage policy, simply click Add, and these are the options we have for each storage policy. A name, whether we intend provision or not for that storage policy, and if yes, how much is the initial provision and what are the provision increments. We can pick a media tier that we will provision from, and we have 3 defined medium tiers of slow, medium, and fast. We can set the bandwidth throttle so that all volumes allocated with this storage policy will have a minimum or a maximum bandwidth throttle. I can set this, for example, to 10 megs a second. A protection level sets whether the storage will be allocated off a RAID 0 or RAID 5 or RAID 6, or RAID 6 being a high protection level. The controller redundancy is low, medium, or high, depending on whether it's a single or HA. And finally, we can set the snapshot frequency to be either daily, weekly, or monthly, and the replication frequency, daily, weekly, or monthly, or never. And for each storage policy, the default fabric can be GigE, 10 gig, SAS, or fiber channel, and then the protocol can be either iSCSI, SCSI, and if it's a network fabric, it can be CIFS or NFS as the standard export. Once we have created our storage policies, in this case entry, standard, and medium, I can then create a storage group. So as an example, I'll pick test. And having created a storage group, I can then choose which storage policy I'll have associated with that storage group. So if I look at premium, if I edit that policy premium is now using the storage policy premium. For each storage group, premium, standard, and basic, I can now map those to different compute groups, gold, silver, and bronze. So if I check bronze, I can see that the only mapping I have from bronze is to basic. Silver, on the other hand, maps to basic and to standard, but doesn't map to premium. And finally, gold maps to premium, standard, and basic. And if I wish to remove any particular mapping, I simply click on the break association or add link. When I now use the OpenStack dashboard, I will be able to choose which compute group, which storage group I want to either run my virtual machines in, or which storage group I want to allocate storage from. Having created my compute groups and storage groups, I simply need to populate the storage groups with storage nodes. So if I For example, if I take my basic storage group, I can see that it's mapped to node 1, it's mapped to node 2, to node not to node 3, etc. So having an understanding of what the storage nodes are allows me to map them into the various storage groups. And in an identical way, I can pick a compute group and put in my various compute nodes into the different compute groups. And that's simply the only configuration we need for Proviso. Once we've now configured Proviso, we can access the OpenStack dashboard. This is the MP-Store Orchestra version of the Horizon dashboard. There are some differences. The first difference is if I go to Images and I look in the image vault and I try to launch an image, I can now see that I have a choice of compute groups within which I can launch the image. I can launch it in the gold, silver or bronze compute groups. And the gold, silver and bronze compute groups will effectively tell the scheduler what hardware infrastructure I should launch the VM in, but most importantly, it will also set the number of VMs per cores, the gold having the lowest and bronze having the highest. And like Horizon Dashboard, I can then choose CPU, memory, etc. completely independently. The second difference between Horizon Dashboard is when I go to create a storage volume, I can pick, again, if it's premium, standard, basic, I can pick my compute group, my storage group, where I'm going to create the storage. And I also have a recap here of what is the storage policy for each of those particular storage groups. The Operations Manager tool allows me to view the CMDB of my cloud, and it allows me to look at the important relationships between various entities in the cloud. So, for example, I can look at the compute group view of the cloud, or racks and their usage, or projects. So as an example, if I look at compute group gold, if I look at the compute nodes associated with that, I can see all of my VMs. I can then see which virtual block devices, if any, are being used by those VMs. Or I can look at my storage group view, and I can see that gold is using all of these, and which nodes and what their status is, which controllers, volumes. And using this, I can browse my entire cloud and all of the interrelated entities within my cloud, and use this for fault finding or monitoring or investigating anything that is not working correctly. And for each volume, I can look at a time series graph to see exactly how that is being used over time for every volume. Another important view is to have the view of projects, so I can see for each individual project which compute nodes they're running on and which VMs are in those nodes. So I have multiple ways of viewing my CMDB and using those views of the CMDB to drill down into either nodes or storage nodes, RAIDs or volumes that may not be working correctly. The Tenant Usage tool simply allows me to pick a time period within which I want to view tenant usage and pick a project. So if I pick this project, Project 239, I can see all of the virtual machines that have been active within this time period and the number of active hours, CPU hours, memory, etc. I can do that for virtual machines. I can also have a view per project of all of the volumes and indeed the network traffic. The Resource Manager tool is a useful tool for looking at and finding out how much of the available capacity within the system is used. As an example, if I pick storage capacity and look at all of our projects, I can see the at a glance the sum total of all the volumes that have been created. I can see how much RAID space is available and what is the overcommitted space in the case of thin provisioned volumes. In this particular case, I don't have a problem with overcommitted space, and certainly I have quite a bit of a headroom. I actually have 3.7 terabytes or thereabouts of headroom, and the number of free disks in my configuration are 0. So this resource graph is, or resource tool, is a very useful way of finding out how many volumes have been allocated from all the storage nodes within the system and how much headroom is available before I run out of space. The last tool I have is the Tenant Administration. The Tenant Administration tool simply allows me to create new projects, new tenants, and to set up their quotas, etc. One addition is the FTP Users. The FTP Users is a tool added which isn't in the Horizon dashboard, which allows the Orchestra to give an FTP account for those people who want to upload new images into the image vault and have those images then added to the Glance image management system.